Good afternoon, Dr. Hassan. My name is Joshua Bowen. I am here to present to you my presentation for a feedback system in a motorcycle suspension. Motorcycles have been around for quite some time. The very first motorcycle that came around, it was simply just a bicycle with a motor attached to it and had very little suspension and things of that sort, and a very uncomfortable ride. As time goes on, suspension was designed better and it was added on and became much more advanced up to this day. Um, my interest in this project originated from my experience with Harley Davidson. I recently worked with Harley Davidson for about just shy about a year. I enjoyed it. I worked in their main facility in their product development, and I was a test engineer, so I dealt with a lot of testing. I dealt with a lot of work to failure and record results and things like that, and different things that I would see. But yeah, that's how I came up about this project and how I came up with the idea about this. Now, the basic design for a suspension is basically a damper and spring combination. The wheel acts as a damper part of the system too, because you have a mass which is the motorcycle itself, that comes down on the suspension, and then the suspension is attached to the wheel, and the wheel has a tire that's full of air, and the tire acts as a dampering system also. Right here to the right, you can see a free body diagram, a basic, to kind of give a visual idea, a basic concept of what goes on with a suspension. And as you can see a spring and damper system connected between the mass of the motorcycle and the wheel and tire mass. And then under the wheel and tire mass, you have another spring and dampering system. And the spring system is very, very small. It's mostly a damper for the most part. And these dampers, and then after the spring and damper, you have a roll profile, which is down there represented as R. Now, the roll profile can change at any time and at any minute. Now, a mathematical model, which I got from our textbook, is basic spring and damper model, which is mass times the second derivative of x plus b, which is the constant for the damper, times the derivative of x plus kx, and k representing the constant for the spring. Now we can take this mathematical model and we can manipulate it and form it to fit our system. Now, as you can see, MC is the mass of the motorcycle, B1 being the first damper, as we saw back in the previous slide, and K1 being the first damper, damper 1, and then MW being the mass of the wheel, okay, plus B2, which is the mass which is the damper, I'm sorry, that is connected between that is between the mass of the wheel and the roll profile, and K2 being more than likely very, very, very small. And then we can equal that, right? We can relate that to B1, okay, because times the derivative of y minus the derivative of x, okay, plus K1 y minus x, right? The roll profiles represented as R, like I said before. The X is the moment of the movement of the wheel and tire. The Y is the vertical motion of the motorcycle. The R will change according to the impact of road conditions, like I said before. The change in R will cause a change in X. Yet we want Y to be as close as 0 because we don't want as much movement in the Y, because the more movement in Y, it makes it an uncomfortable ride. It makes the ride uncomfortable, even though it's probably impossible for it for Y to just be 0 in a realistic situation. But we don't want as much movement in the Y, basically, when it comes down to it. So here's a CAD design that I've done of a kind of give you an idea of a spring dampering system for a motorcycle suspension. The overall scope of this project is to apply a feedback system to the suspension so it can be able to recognize the turbulence and the difference in the displacement of X. And the displacement of X is displacement in the wheel. So when the wheel has a large impact or a constant bumping or a constant impact, the system can adjust the suspension to adjust and have an even level for Y, right? To be a more smoother ride for the rider. And knowing roads like Houston, you have constant speed bumps, you have constant bad roads and cracks in the road. Sometimes you're if you're out in the country, you're on a dirt road. It recognizes that dirt road, and it doesn't make it as it doesn't. What the system would do, it will act upon that based on the road profile and according to how the wheel is moving and the motion of that wheel and the shock that the wheel is getting from the road profile. But that's the overall idea of my project. I just want to say thank you for listening. I've really enjoyed your class, and I look forward to doing more and exploring more about systems. And thank you, sir. Thank you.